Hello everyone. In today's video, I'm going to be showing you how to make a fairly advanced calculator on Scratch, where you can add, subtract, multiply, divide, and you can also put decimal input or sign your numbers by making it positive or negative. So, for example, if I try to add 9 and some large number, that works. And if I try to divide it by something random like 32, it gives me a decimal. And if I try to, I'm going to press the clear button now. I'm going to try to make a recurring decimal. So as you can see, it goes on until it fits right in the screen. I'm going to multiply this by 3, and I'm going to try subtracting this by 6. And as you can see, you can also have negative numbers. If I want to make this positive, I'm going to try multiplying this by -1. You can do that as well by multiplying it by 1, and then you can sign it to be negative, and then now we get 5. So I'm going to show you how to make this. And although this calculator does not have every function that there is on a scientific calculator, such as sine and cosine, you can easily implement those after watching this video. So let's get right into it. So first, you want to make each button that goes on the screen and have them in a nice regular grid-like layout. So for that, I'm just gonna start by drawing our button. So for that, I'm just gonna do a white square like I did in the demo. So hold the shift to make a square instead of a rectangle. And I'm going to add a gray outline. And okay, I think I didn't select this. Yep, I think that's a bit too. Okay, there we go. Gonna make it a bit lighter and make this larger. Okay, should I held shift? Yep, there we go. Maybe that's a bit too large. Oops, I distorted my square right there. Oh, you gotta hold control, not shift. Sorry, I think I said the wrong key. So let's make this 12 and a little larger. Yep, I think that's a good size. So, okay, maybe a bit smaller. Yep, I think that's a good size. And you want to make 18 of these because they fit the screen. But before we do that, we do want to add some basic code into this so that when we duplicate them, then we have that code in every single button. So first we just want to, I think the first number would go somewhere around here. So I'll just go ahead and place that here already. And I'm just gonna make this, yeah, I think -192 and 20. That's a good place. Yep. And after that, I'm gonna just put some basic code. So we want to do something when this sprite is clicked. So we have our when this sprite is clicked button. And we also have to let the program know that the button is clicked. So for that, I'm just going to create a variable called button. And we're going to set button to 1 because we're going to make this our 1 key. So let me just go ahead and add that. Maybe a bit too big. Yep, there we go. So we have our 1 key over here. And this 1 is basically telling us what key it is, so that when we do process our numbers, it knows what the button clicked has, if that makes sense. And then we want to broadcast some message. So let's just make it called button pressed. And we want to wait. So yeah, that's going to be the base code for the button. And now I'll duplicate this about 18 times, or exactly 18 times. But if you're making more buttons, duplicate it as many buttons as you have. So after you have duplicated it, just put all the numbers in. So I'm gonna make this 2, 3, 4, 5, then so on until I have everything I need. So you can use this as a reference. You can pause the video here and use this as a reference. So after you're done, you're gonna have everything that you need, but they're all gonna be scattered like this. So I'm gonna show you how to organize these. So I did use a pretty manual method, but although there are better methods out there, but I'm just gonna show you how to simply, organize them by just changing the go to over here. So the top row is all gonna have the same y coordinate. So I'm just gonna put that there. 0, 3, 1, 2, 3. That goes there. So we can use this as a reference and do 1, 2, 3 AC plus minus. So 1, 2, and then this is also going to have a y coordinate of 20. So this is going to be about 1 minus 115 because we're trying to make the space between these equal. So if we take the same space between this and this, we can make this minus 38. So now the space between 1 and 2 and 2 and 3 are equal. And if we follow this, next one is AC. So you can do this for all of them. And if you want to go to the second row, you can change the y coordinate this time. So second row is going to be 4. So 4 is going to have a y coordinate of, in my case, I'm going to make it minus 57. And the x coordinate should be the same as 1, so that it's right underneath 1, but it's below it, if that makes sense. So there we go. And you want to have everything in the row of 4 have the same y coordinate. And then finally for 7, I'm going to have a y coordinate of minus 57 because that's we want to keep the gap between 1 and 4 and 4 and 7 the same. So, okay, I think I might have, yeah, I think minus 57 was what we did for the last one, so gotta make this minus 134. Yep, there we go. So you want to just make everything in 7's row have the same y coordinate as 7 and the same x coordinate as the stuff above, so that you have a nice grid. So after you're done, your grid should look something like this. And now we want to change our button for every single one because not all of them are 1. And you can of course name your sprites, but I'm gonna skip that for this tutorial because it would take a while. So let's make this 2, make this 3, make this 4, make this 5, make this 6, make this 7, 8, 9, and 0. And for the special ones, for the decimal place, you can just add a dot because that's the decimal place. And for the multiplication symbol, it's no different, but this time instead of the multiplication symbol, I'm just gonna do a star because it's easy to type and you don't have to like search up multiplication symbol and stuff. And for this one, I'm gonna do slash. For this one, a plus. This one, a minus. And for the AC, it's a bit different. So we're gonna have more stuff changing for AC, and we'll get back to the AC stuff later, but for now we do not need to do anything. You can kind of leave this blank for now. And also for the negative, I'm just gonna set this to minus because we already have a subtraction thing. So I'm gonna set the button to minus, and I think the rest is fine. The equal is also going to be an equal. So yeah, now we have our sprites for the keys, or the buttons that you're going to press to do the calculations. But now we also want the display, so let's make another sprite for that. And for the display, we're actually going to have multiple costumes that have each number for them. So let's make costumes now. So we have 1, and we're going to duplicate these until we have 1 2 3 4 5 6 7 8 9 0 minus and decimal place. So after you have all of these, so 1 2 9 and then 0 minus and then decimal place, you're gonna have to add the code for these now, so actually calculating the solution stuff. So first we want to make this go over there. So for that, we're just gonna make it go to, I think y equals 100 is about here. So I'm gonna just make it go to something y equals 100 for now. And I'm gonna have to start making some variables now. Just gonna get rid of the my variable. Now let's go back to our AC sprite, and there we want to change a few things. We kind of want to clear the stuff shown on sprite 19, which is our display. So we're going to have a variable called display. It's basically what it displays, and we're kind of clearing the display. So whenever we type something and then clear it, okay, I think I didn't run the program there. And then clear it, yeah, it becomes 0. So we want to do that. And set display to 0. And also we're gonna have a few more variables such as solution, which is gonna have the file, which is gonna store the final solution. And we're also gonna have a variable called operator, which is basically the plus minus, division or multiplication, or if you have more stuff that you're adding to your own, then yeah, those will be in the operator. And we're also going to store the previous answer, because the previous answer is often used. So if you do 3 times 3, for example, and we get 9, we can use this previous answer and then further do stuff with it. Minus 2, get 7. So we also want a previous answer variable. And for all 3 of these, so solution, operator, and previous answer, we're gonna all, where did I go? Yeah, okay. We're gonna all set them to blank because we want to kind of clear everything when we press the clear button. And we also want to broadcast something that actually makes the thing happen. So gonna broadcast show, and we also want to wait. So let's get that block instead. And yeah, so we have our code for the AC button, and some of this might not make sense until we actually make the display. So let's go ahead and do that now. So in this tutorial, I'm gonna use a lot of custom blocks just to teach you guys how to use them, because it's a good use of it in this, because there's a lot of the code being repeated, but you don't want to always have to duplicate the code. You want to make it adaptable. So for this, we're gonna first, this is the display, so it's gonna receive the button pressed. It's gonna the button press is gonna be received by the backdrop, which you're gonna use later for the processing of the calculations and stuff. But here we're gonna have we're gonna receive show, and also I think our equal to button, which is over here, it's going to later it's going to go to the backdrop, and it's also going to add, it's also going to broadcast something called show answer, which is going to actually show the solution up. So I'm gonna make a message called that show answer, and it will make it more sense when we make the processing happen in this backdrop sprite. We're just doing the processing in the backdrop instead of making another sprite for it, but you can also make another sprite for it if you want. So when we receive show, we want to basically place the number somewhere on the screen, but we don't really know where to place it. For example, if we do, let's clear that, and 1 divided by 3, we don't know where to place each one over here. So it might be here or here. We don't really know. So we need to, make code to make it show up neatly like this. So we're going to have a block called place, and we're also going to have this called number, an argument called number. So let's add that over here, and we want to place some text which is going to show up. I'm just going to make a variable called text and place the text whenever we have the input. Whenever we need to show the 0 or any other solution. For show answer, we want to place the answer. So let's make a answer okay. And okay, we don't need the solution if you have an answer. Let me just change that to answer real quick. Yep, I just got those mixed up. Let's just use answer instead of solution. So now we have, okay, I think we didn't use solution anywhere else. Yep. So now we probably should do the processing before displaying the actual answer. So let's go to the backdrop, and we want to receive button pressed, and we want to know what kind of button it is so that we know what to do with it. So if after the button's pressed, if it is a number, so to know whether it's a number, we can do if so button, we here we set button to whatever key it is. So if button has a number, so we can do, let's make a string called 1 2 3 4 5 6 7 8 9 0. So we want to check if it's a number. We can do that. Then we want to basically know that it's a number. So when this happens, we want to join button. So basically join it to the answer. So I'm gonna make a block called join. So here we're using a lot of custom blocks, and okay, probably should also add argument there. We can name that number. So we want to join button, and then we also want to know whether it's a decimal place. So just do button equals decimal place. And also if it does not already have a decimal place. So for that we want to do if the text does not contain a dot. So let's do text contains dot. We want to do does not contain that. So let's do that. Then we want to also join button, and we'll make the join button here just a bit later. And yep, I think that's good. And we also want to know whether it's a operator, which is the plus minus division and multiplication. So for that we're going to do something similar here. So instead we're going to do minus times and division. And here we want to simply just, but this time we don't want to join it to the, here what join does is basically, if you have, let me clear that. Then if you have a 2, then you can add a 4 and kind of just joins it. But you don't want to join a multiplication symbol here. So we're just going to make another block called operator. Or apply operator, that makes more sense. And make a input, which we can just call it number again. Or actually, it would make more sense to call it operator because it's an operator, not a number. So let's do apply operator, or it's a button because we have the button thing there. So yeah, do that. Then for if it's an equal to sign, so if it's an equal to sign, we want to actually solve whatever is given. So I'm gonna make another block called solve, and we don't need any arguments for that. Let's put that in there and get rid of these. And finally, you want to know if it's this sign, which changes the sign of the, makes it negative. So if button equals minus, we want to change the sign. So let's just name it change sign and put that here. It's a little laggy today. Yeah, there we go. And now we need to make these actually work. So first we want to, actually before we do any of these, we want to make sure everything's cleared when the game starts. And since this is the processing code thing place, it makes sense to do it here. So let's set previous answer to 0, just everything that you don't want to have carried on every time you press the green flag. Let's also set the answer to 0 or blank, if that makes sense. Set these to blank, and then set operator to blank as well. And we want to set text to 0 because that's what we're gonna show up on the screen. So set text to 0. And to actually make these show up, again we want to broadcast show. Yep, there we go. So it clears, and I think that is good. And now we want to do define, let's make the join first. So for join, we want to clear the answer first, and then we want to do if, where'd it go? we want an if else statement, because if the text has a 0, or I mean the text is 0, whatever's on the screen is 0, then we set, so you don't want 0 to, so let's show that here. When you have a 0, you press 2, you don't want it to show 0 2, you want to get rid of the 0 and put a 2 there. So for that we can do text, we're going to set text to number, and then we also want to, or otherwise we want to set text, we want to join it, so we can just do join. So if I add a 4 here, it's not going to replace the 2, it's going to go next to it. So we want to join text and also number. Yep, there we go. And let's broadcast show. Yep, there we go. And now let's do the change sign. Right. Let's do that a bit later. Let's do the solve thing first. So the solve thing does have quite a bit of code, because it's basically solving the thing. It's kind of the main part of the calculator. So we want to first make sure the answer's nothing. So if answer's nothing, so if answer is equal to nothing, then we also want another if statement inside. So we're kind of checking if the requirements are met for the actual solving to happen. So if the operator isn't blank, we don't want the operator to be blank. So not operator is equal to blank. And also we want to make sure the operator is one of those plus, minus, times, or division. So let's do and. Yep, I think that is good. Then here instead of button we want operator. Yep, there we go. Then we want to do stuff according to what the operator is. So plus, minus, division, or multiplication. So let's have one for each, or actually let's just make one and then duplicate them. That would be a better idea. So if operator is equal to plus, then we wanna, so here's where the answer comes in finally. So set answer the previous answer plus text. Yep, there we go. And now we just duplicate this 4 times for each operator. This time we do minus, and previous answer minus text, and then here it's times. Can we change it here? No, we can't. Scratch should add that, I feel like, but it's alright. And here, previous answer divided by text. And change these to times division. And put that in there. And actually, we do want an if else statement here. So let's replace that, because else we want to just set the answer to text. So oops, put that here. And else we want to set the answer to text. and then put all of this inside here, and we want to broadcast show answer, and we want to set operator, where's that? Yeah, okay, operator to blank, and also set text to 0. Yep, there we go. So yeah, now I think we're done with our solve block. Now we want to do the operator block. I think it's a good order to do in. So let's do if. So again, we want to check if it answers blank. So if answer is blank, then we solve, and we set operator to button. So now this part kind of makes sense because we're checking the operator after the button's been set to the operator. And then we set previous answer to the answer that was just there now. So that makes sense. And we also set text to 0 here. Finally, we want to do the change sign code. So for change sign, we also want to check if answer is blank again. So just get an if else statement, because it depends on whether the answer is blank or not. So if answer is blank, then we set text to 0 minus text. So that changes the sign. 0 minus text. We do not need to show these. 0 minus text. And we broadcast show. And otherwise, we want to show answer. Yep, there we go. And actually, we don't want to subtract text here. We want to subtract the answer. And here we set answer to. Yep, there we go. So now we have all the blocks. And now I think it makes sense to actually display our things on the screen. So we can go back to our display sprite thing. And now we wanna, now this stuff kind of makes more sense, hopefully. And let's make another block called display number. So after placing it, we want to actually display it. Okay, display number. There we go. And just put it over here. And when we display it, we want to make it go there and show. So it makes sense for this to go here. And now we're gonna make this using this stamping tool. So for the stamp, you need the pen thing. And so let's erase all before that, just so that we don't have like the old numbers still stamped on there. And we also want to know how many digits there are. So we can do number of digits as a variable, just to keep stuff organized. So let's just set the number of digits to the length of this input. Input's kind of an ugly name. I'm gonna change it to number. So there we go. Number. Yep, it changed. And if, and we wanted to not exceed the screen, so I think here I chose 12. So I'm going to do the same thing here. But if you want it to round faster, you can reduce the value So if number of digits is less than 12, then we set number of digits to 12 so it cuts off, doesn't keep going off the screen. And we want another variable called counter, because we're using this in a loop, and set this to 1. And then we also want to vary the x position of each digit on the screen. So let's make a variable called x position, xpos for short, and let's set this to 240 and start, because that's like on the right of the screen. And then repeat, and this is where the number of digits variable comes in handy. We want to set, and want to know each digit, so let's make a digit variable. We want to set digit to, we're kind of looking at each letter of the looking for the letter. We're kind of looking at each letter or each digit of the input value. So letter, then do that minus counter, then number of digits plus 1. We're kind of going through each digit to display them and assign them their x value. And we want that of our number. Okay, probably should have duplicated that. Yep, there we go. And set x position to, or actually we want to reduce the x position, so change x position. Where is that? Yeah, okay. Change x position by minus 35. And then we want to display the number. And then, actually we want these inside here, yeah, okay. Then we want to increment the counter by 1. So change counter by 1. Yep, there we go. And now, instead of a random x value that we have here, we can set this to xpos. And also we have all these costumes, which will come into handy now. So we can switch costume to the last costume. Then we're actually going to utilize a list here containing all the costume stuff. So just name it, what's the appropriate name? Probably like digits. And I will make 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, minus and dot, same as over here. Go ahead and hide the list, and then we want to repeat, and then we want to get the item number of digit in the list, and then that many times we want to do next costume so that we're at the right costume. And then we show, and then we stamp, and then we hide again. And let's just try running our code. Okay, probably shouldn't have all these dots here. Okay, so I just realized I put this inequality thing the wrong way. So let's switch that around. Number of digits and 12. Okay, we can hide that list again. I also just realized I meant to put item number here. So item number of digit, and okay, let me just fix that back. and hide this. So yeah, there we go. Now there's a 0 here, and 35 times 6. Yep, our answer shows up. We can clear it. Let's try putting a sign on this. So yep, negative 65. Let's divide that by, I don't know, some large number. Yep, there we go. It's a negative value. Let's try getting a recurring decimal. See if it cuts off here. Yep, it does. And finally, let's try adding a decimal. So 6.5. Subtract 36. Yep, there we go. So if you found this video helpful, please leave a like and subscribe, and I'll see you in the next video. Goodbye.